In the last lecture, we talked about how computers understand only machine code. That is, if you want to give your computer instructions in the form of your program will be translated to machine code. This translation is done by another computer program called the compiler. So your program will be translated into machine code and the computer will understand it because it's the only language that it can understand. What is machine code? Machine code is a set of instructions consisting of zeros and ones, where 0 denotes the off signal and 1 denotes the on signal. We use a standard called the American Standard Code for Information Interchange, and using this standard, it's called the ASCII standard. All characters of the alphabet, and virtually every character or every symbol that you can think of, is given a decimal value which can be translated into a series of ones and zeros called the binary numbering system. It is called the binary numbering system because it consists of only two numbers, 0 and 1. So it's a numbering system to base 2. So for example, the letter A in alphabet is given a value of 65, which can be translated to base 2 to binary to be 10000001. So how is information, how does the computer store this information in its memory? It's actually quite simple. The computer stores information on memory, on its memory, whether it's RAM or storage, as a series of zeros and ones, and the smallest unit of memory is 1 bit. So if you have, for example, 1011, each number is referred to as 1 bit. And once you have 8 bits, you have 1 byte. So 1 byte equals 8 bits. And that's how information is stored. So you have, for example, if you look at a memory of your computer, you would probably have about 4 gigabytes. So it's the unit to quantify memory is bytes, and each byte is of course 8 bits. How do you convert base 2 numbers to base 10? We human beings understand numbering systems that are to base 10. So we have 10 digits: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Binary is to base 2. So if you have the value 1, 0, 1, 1, and that is 4 bits, this is to base 2. How do you convert this to base 10? So what is it to base 10? Well, the way you would do this is, let me just change the color here. So we have 4 spots because we had 4 bits, right? And so we have 1, 0, 1, 1. Here is the first spot. So we start counting from 0, spot 0, spot 1, spot 2, and spot 3. Okay. So the way we would convert this is we're going to say spot 0, we have a 1, so we're going to have 2 to the power of 0, plus spot 1, we have another 1, so that means it's on again, so we're going to say 2 to the power of 1, plus spot 2, we have a 0. Because we have a 0, we're going to ignore that. We're not going to count it. We move to the last spot, which is spot 3. We have a 1 again. So we're going to have 2 to the power of 3. And 2 to the power of 0 is 1, plus 2, plus 8. And that is 11 to the base 10. So 1, 0, 1, 1 to the base 2 is in fact 11 to base 10. And that's how the conversion is done. So let's try to do it the other way around. So for example, if we have 11 to base 10, how do we convert that to a number in base 2? Well, this is quite simple. The way we would do it is we're going to do it using division. So we're going to say 11 divided by 2. So you're going to have 5 and you're going to have 1 as remainder. So this is remainder and this is the quotient. Then we're going to take the quotient and say 5 divided by 2. 2 goes into 5. Sorry, I apologize. So 2 goes into 5 2 times, and we're going to get 1. Then we put the quotient back here. Now 2 divided by 2 is 1. And remainder is 0. So then, starting from the last quotient, that's our number. So our number is going to be 1 and all the way back up. So in fact, we're going to have 1, 0, 1, 1, and that's to the power of 2. So 11 power of 10 equals 1011 to the power of 2. So that should be quite clear. So for example, if we have when I was going through engineering in the beginning, there was a recurring joke. They were saying there are 10 types of people in the world: the ones that know binary and the ones that don't. So if you can understand this joke, that means you've been doing pretty well so far in the lecture. One more thing I would like to talk about in this lecture, and that is what is the largest. So if you have 4 bits, what is the largest number you can fit in 4 bits? Obviously, in order for it to be the largest number, you need to fill everything with 1s. So if you have 4 1s, that's the largest number, and that is, what is that to base 10? This is going to be 2 to the 0 plus 2 to the 1 plus 2 to the 2 plus 2 to the 3. And that's going to be 1 plus 2 plus 4 and plus 8. And that is 15. So 15 is the largest number you could fit in 4 bits. One thing you should note that I'm talking about unsigned numbers. So I haven't talked about how negative numbers are going to be represented in binary, only positive numbers. As an exercise to you, you should now tell me what is the biggest number you could fit in a byte. So if you have 4 bits, what's the biggest number you could fit? Obviously, it would be all 1s. And what is that? So do that. Thank you for paying attention. See you in the next lecture.